Good afternoon, everyone. Thank you for joining me. My name is Meera Viswanathan, and I work as the product manager for the .NET team at AppDynamics. Today, we're going to be talking about some of the trending technologies in the .NET field over the past few years, and the visibility that AppDynamics as a company provides into these applications to help you debug and isolate issues you may have, and proactively and reactively resolve issues. So let's start off with the cloud. Obviously, the cloud is a very prominent platform at the moment. So how many of you have some presence on the cloud at the moment? Raise it. And how many of you have used Azure? Perfect. OK, so Microsoft Azure, hold on. Sorry, guys, I'm trying to advance the slide here. Sorry? It's this one, right? Oh, OK.
Go ahead.
All right.
Just like this button. Oh, wow. Oh, your thing's not. Did it freeze up?
I'm not sure. I could just click this right here.
Yeah, go ahead.
All right, cool.
Let me see, go ahead.
Sounds good. So obviously, we're going to be talking about Microsoft Azure, Microsoft's service as a cloud. So what is the cloud? So a very basic explanation would be this little inverted pyramid that we have right here. You have on-premise applications where you have access to everything starting from your network all the way up to the application and data. I mean, this is fantastic. You can access the machine. You have full visibility into exactly what may be going wrong. But this also has an added cost of having to maintain the hardware, deal with scalability if you have a high amount of load, deal with the idea that operating systems have upgrades, and on top of all of this, provide the application upgrades or application improvements that your customers require. The second option that we have, the first layer of abstraction the cloud offers is infrastructure as a service. So infrastructure as a service is basically when you have access to everything from the operating system onward, but the hardware is actually maintained for you by the company giving you the cloud, providing you the cloud service. I'm sorry. So basically, with infrastructure as a service, you can log into the machine, set up operating system variables, set up your operating systems, but operating system maintenance, like upgrades, are still on you. This is great because you don't have to worry about the hardware anymore. It is extremely cost effective. And if you want to spin up a new instance, it's actually very, very simple. The next layer of abstraction is PaaS, or Platform as a Service. So Platform as a Service is essentially when you have access to the application that you're deploying, but everything else is automatically taken care of for you. So operating system upgrades, the maintenance, and all that stuff that we talked about before is taken care of by Microsoft. Now, the reason this is extremely cost-effective is things like scalability no longer become your concern, and you can use your local machines for fine-tuning your own applications. So high load is something where they automatically spin up new machines if necessary, and you also have the ability to focus on just your application, greatly speeding up the time to market. And the final offering that we have is SaaS. SaaS is basically, obviously, when you have everything is taken care of for you, including the application and the data. So all you have is a way to visualize your data, use that data, and provide the appropriate response to the customers that you have. So given this is the case, it kind of explains why cloud is so important. But if you look at the monetary trends in the industry, it seems like the cloud from the year 2013 to the projected year 2018 is expected to grow to almost a $400 billion industry. And Amazon, outside of Amazon, Azure is the most prominent platform. It processes 1 billion requests per day. Traffic has grown over 500%. And 57% of Fortune 500 companies at the moment have some presence on the Microsoft Azure platform. Paid subscriptions have grown by 120%, and at the moment, about 275 to 300,000 websites are hosted on the Azure platform. So Microsoft obviously has a significant cloud presence, and they offer it in what we would consider, what I see as applicable to the application performance monitoring software, or the Microsoft Azure Pack that Microsoft calls it. There are 4 options over here that are important to the application performance monitoring software. One of them is virtual machines, which relates to infrastructure as a service, as we talked about before. Database as a service, which is more of a platform as a service, where you have access to the data, you have the ability to insert, delete, remove tables, but no access to the machine that the database is actually hosted on. So if that machine fails over, this database is automatically moved on to another machine with you having to do no maintenance whatsoever. Then you have the service bus, which is more of the Microsoft storage system. The service bus also, under the Azure storage, you also have Azure Files, Azure Blobs, Azure Tables, all that help you maintain the state of your current application. The final thing that we have is Azure Web Apps, which is basically websites that are hosted on a platform as a service environment. This is where you have access, like I said, just to the application, but not to the machines whatsoever, which is a little different or just on the opposite end of the spectrum of virtual machines. So this leads us to the use cases that people have, specifically related to AppDynamics. And I'm actually going to pass the mic over for a little bit to the product marketing manager, Anand.
Thank you, Mira. So Mira asked me to talk about some of the use cases that our customers are doing for when they're going to cloud. First, I mean, it's not a surprise here, monitoring cloud applications, right? So applications, business transactions are cutting across, going across on-premise and on cloud. So that is the application that could be running on-premises, making web services call to services deployed in Azure. So monitoring those, you can drill down to the code level details and all the AppDynamics benefit of alerting, baselining, and everything you get. So that's the base use case that customers are using. And Mira will be kind of getting into the details of these later. But a couple of other use cases that I've seen customers using is migration use case. So when you are thinking about planning for migration to cloud, you're running your applications on-premise, websites on-premise, and then considering to go to Azure, then you could baseline, it could establish a performance baseline in premises. And then after you migrate to Azure, you could compare with them. Functionalities like compare release help you do that. So many of our customers are using that. And this is a pretty, I would say, a common use case, not only for Azure, but for other cloud services as well. And the third use case that AppDynamics could help is scaling, auto-scaling. So we have many cloud connector extensions, including one for Azure, that you could set up. You could set the health rules, policies, when should we auto-scale. It could be number of calls coming in, workload, whatever that is. Based on that, you could set up the health rules and policy, and as an action, you could call the work through the Cloud Connector extension to do the auto-scaling. So using AppDynamics, you could, the 3 key use cases that I talked about, you could monitor, of course, you could get help during the migration, plan for it, and then kind of test pre and post migration, and finally, you could auto-scale. So these are the 3 use cases that we see. Let me hand over to Mira for the rest of the presentation.
So with these use cases, we kind of smoothly transition over into how does AppDynamics really help you in this cloud environment. So debugging the cloud, a very simple use case. So you are a biz DevOps. You've entered the office, and you have a simple application, a front-end web app that retrieves information from a Java and a .NET application. The Java application is running on an Amazon instance. Your .NET application is running on-premise. And you have information that you're retrieving from it, which are the latest list of movies that are running in the theater right now. This then goes into a service bus queue. You put it in the queue. There's a background task that's running that processes this queue, receives the information from it, parses the data, and inserts this information into the database. Now, you see this entire system kind of visualized for you on the screen right now. You obviously have the web worker role pattern with Azure Cloud Services. You have database as a service, and we also support Azure Tables and Azure Blobs and Azure Files. And you obviously have the service bus that's being talked to. And then you see a mixture of dotted and solid lines. The dotted lines represent async transactions, which we'll get into more detail later in the presentation. And we have solid lines, which represent just simple synchronous transactions. So this is great. This is what you're expecting to see. But someone comes in and tells you, hey, by the way, customers have been trying to get access to the latest movies, and they're not seeing it anymore. It seems like the database is stale. So what exactly is going on? Let's try to find that out. So you come in, you log into AppDynamics, and this is what you see. Obviously, there's a huge set of information that's missing over here. You just see the web role, you see the database, and you have to see the service bus queue, but it seems like the worker role doesn't exist anymore. So what's happening over here? If you notice the top right corner, you have something that we call server crashes. It says it has a little yellow sign over there, kind of indicating that there should be a problem. And if you click into it, you see a list of CLR server crashes that currently occurred. And it seems like the worker host that we were talking about specifically has crashed. Now, the reason this is extremely useful is while it's important to also get information about the metrics that are coming into your application, it's also important to understand why your application crashed or what happened with it. What was going on in the machine at the time that this crash occurred? And if you have 15 or 16 worker processes that you're trying to monitor all at the same time, you also have information about the tier and the node that this specific process was running on, giving you the information as to exactly what computer you need to be logging into to identify what the problem might be. So let's click into it and see what happened. You see a simple server screen that says that the tier that it was running on is a background service bus, which is a background task. You have the fact that the process crashed with event ID 1000, the event log. And upon clicking further, you get information as to exactly what was going on in the event log at that time. You can also click into machine snapshots, and that'll actually give you the information as to see whether the memory was extremely high or the CPU was extremely high at that time, giving you information as to maybe that's exactly why the bus crashed. Or you could just log in and try to identify what may have caused the issue. Change your application to better handle these kind of crash applications so we just don't die, or the worker host doesn't die automatically. So this is one thing. OK, fine. You know, your customers are super happy. You responded and diagnosed their problem and fixed it as soon as you possibly could, possibly within just a day. But you sometimes want to be able to proactively figure out that there's a problem as well. And this is kind of where we go into slow and error transactions or other metrics. So I'm going to go specifically into the case of slow and error transactions. You come into your application one day, you log in, and you see that there are 22 slow transactions in a span of 15 minutes. Obviously, there's something going on, and you want to be able to figure this out before it hits the customer, and the customer sees that there's a problem. So you enter into it, and you see a little snapshot. The snapshot tells you that there were 4 exit calls made, 2 HTTP calls, and 2 ADO.NET calls, or 2 database calls. And it seems like a single HTTP call took 14.481 seconds, a significant amount of time, especially in a time when we expect responses to happen within the second. And then you go further into it, and you see that 93.7% of your time was spent on this specific transaction, and it seems to have occurred exactly on this line of code, giving you the information as to where you need to go to be able to resolve this issue. Then you go back to your main screen, and you notice that there are 265 errors as well. So what's going on with this? You go in, there's a side on the bottom left corner which says potential issues. And it seems to be indicating that the same web request seems to be causing the problem again. And then you have a drill down button, which you go into as well, and this gives you the full stack trace. So it seems like the information is not, the call into the .NET application or .NET on-premise application seems to have a problem. It may be a network issue, but you know exactly now which call to look into and what problem it may be. So with this, we also notice that on-premise to cloud is becoming more common in the industry, because this is exactly what it is. It's an on-premise to cloud connection. So with people transferring onto the cloud, there's still legacy applications that they may have running on the on-premise applications, on the servers on-premise. And you want to be able to see information flow across both platforms. So common technologies used in this case are BizTalk and nService Bus, something that we support out of the box now. So if you have a simple BizTalk application where you have a front-end client, you send that information into the BizTalk server. The BizTalk server processes. Maybe you have an XML file that you just want transformed, and that XML file then sends that information to the WCF service in the back. And again, you can see that there's both synchronous and asynchronous calls being made, which are fully visible in this flow map right here. The other thing that we have is also nService Bus. nService Bus is obviously very commonly used when you want to be able to transition information from one server to another. And reading and writing to the nService Bus in both an asynchronous and synchronous pattern is completely supported. And I've been using the word asynchronous quite a bit. So what is it, and what does AppDynamics do to give you visibility into those transactions? So we come into asynchronous programming. I'm going to do a little bit of reading from the slides to say asynchronous programming is a means of parallel programming in which a unit of work runs separately from the main application thread and notifies the calling thread of its completion, failure, or progress. So the first time I saw asynchronous transactions, the easiest way I found to identify with it was basketball. And so with basketball, it's basically when a person is trying to shoot the basket or put the basket, to shoot the ball into the basket, he actually has to wait until the ball is actually passed to him. But while he's waiting, he still has to continue playing the game. And that's kind of how I see what asynchronous transaction is all about. You're reading from a file, or you're writing to a file, and you're waiting for this operation to complete. You don't want to be blocked on this operation. You still want to be able to say that the rest of your method is going to continue executing at the same time. So this is a little code snippet that I got off the MSDN website that talks about asynchronous transactions. And you can see a slew of arrows that go all over the place, telling you that there's an await, there's a get string async, which then returns execution over here, comes back and executes the next method as soon as it receives the notification that the call is over. This is kind of confusing. It's hard to trace exactly what's going on and what's happening in this asynchronous transactions. And async has obviously gone through significant evolution in the .NET framework. It started off with event-based asynchronous processing in .NET 2.0, went into APM, or the asynchronous model with the iasync class in .NET 3.5/.NET 4, and then eventually moved into the task-based asynchronous programming model. I'm not going to talk too much about the event-based because it's pretty much obsolete in the industry right now. But with the asynchronous pattern, we have the APM model used to be a begin and an end send. For every begin, you needed an end. And this notified that once the call was complete, it needed to invoke the end send. This is kind of starting to get phased out, still present in the industry and still important to monitor. But it's getting phased out and coming out into just a single method that just does a send async, which is all encompassed into one method, like I mentioned. The other thing that we have is the async await pattern, or async state machines. With each await that's called, the async pattern then creates its own machine state. So let's say you're writing to a file. You're writing to a file in a single method. And while you're writing to the file, you call an await, and you say, I still want the rest of my method to continue executing, or the calling method to continue executing. So what happens is that your machine automatically creates a state of the program that it needs to come back to once the call returns. So this is kind of what the async state machine in the latest .NET framework entails. So we come back to this. And the reason I bring this back is you can see both programming models being used. But again, it becomes very difficult to find out exactly what went wrong or why it went wrong, or more importantly, to really trace back transactions. You don't want to have 15 or 16 pages of code open in front of you trying to figure out exactly what went wrong. So this is where AppDynamics comes into play. We work both on the on-premise and on the cloud environment. So on the on-premise environment, you come in one day, and someone tells you that the checkout transactions are extremely slow, and you're not able to process payments anymore. Problem? I think so. So you look at the business transaction list, and you notice that there are 21 very slow transactions. You click into it, and this is the flow map that you see. a flow map that is automatically rendered for you and visualizes exactly what's going on in the application at the time. When you look at the transaction snapshots for this specific business transaction, this is what you see. You see the user experience is extremely slow. You see little icons telling you that there are very slow transactions and the tiers that they seem to be initiated from or the applications they seem to be initiated from. And then at the bottom, you see a list of snapshots that are associated with this specific business transaction. You also see a list of potential issues. And in this potential issue, you notice that there's a WCF call that seems to be taking 10.5 seconds. And you also notice that there is the checkout, which is exactly what we were considering before, seems to have taken 5.3 seconds. And then on the right, you also notice a full call graph telling you exactly what's going on, including the exit calls that were made or the WCF calls that were made. And it seems that there were 2 calls that were made. Now, let's kind of see how this is visualized in the cloud environment. So in the cloud environment, we have a similar scenario. You have the web role talking to the queue, and you notice that there are some potential issues on the bottom left corner. It says that you were trying to write to the queue, there was an asynchronous entry point, and there was also a begin send, which seems to be where most of the time was spent. You click into the transaction even more, and then it tells you that a significant amount of time was spent specifically on the begin send transaction. Almost 35% of your transaction time was spent in that. So this tells you that there's a problem with service bus, possibly with the service bus network latency, or possibly just that the begin send transaction is taken too long. You go into the specific transaction, and you notice that there's an exit call. When you look at the details of the exit call, you also notice that the asynchronous property is actually set to yes, telling you that this was an asynchronous transaction, and this is exactly where we seem to have a big issue and what we need to identify. I seem to have completed much earlier than expected. So this kind of concludes exactly how AppDynamics visualizes both the cloud environment. And I kind of glossed over a big component, which was Azure Web Apps, something that is coming up in the upcoming release as a beta availability. And with the concept of async, we are going to give you full end-to-end visibility, starting from an Azure Cloud Service to an Azure website, all the way whether you have a service bus, a synchronous, or an asynchronous call happening in between. So to kind of sum it up, the reason this is extremely critical is the cloud architecture is very elastically scalable, very reliable, automatic resource management, and is extremely cost-effective. The asynchronous applications have fast response time, and they have an ability to scale with high loads. These are 2 patterns that are becoming more prominent in the industry, specifically with the idea that response times are becoming more and more critical. It's extremely important that we are able to provide information and diagnose problems faster with these 2 specific platforms, just because of the fact that we have high loads and response times, both of which are critical factors in application development at the moment. Thank you very much. Yep. If anyone has any questions, feel free to stay back, or we can pass the mic to you to ask. Yes, please.
You're the .NET Program Manager?
I am the .NET Product Manager.
Okay, so I have a question. When are you going to get line numbers for us?
Line numbers?
Yeah, like so the Java gets a little up, right? So when we're tracing down through the call stack on the Java side, we get line numbers.
Okay.
Then on the .NET side, we don't.
Well, that's parity that's important, and definitely something that's getting worked on. Yep.
And what about the need to constantly recycle, the CLR when we make changes to certain
So that's actually coming up in the upcoming release. If you make a change to the controller configuration, you no longer need a restart with a simple application flag. We actually have that at the demo booth, so if you have any questions about that, we can definitely show that to you. Yeah. don't think there's any.
So do you have a timeline for when Azure Web? You said the next release. When is the next release? What's the date?
The upcoming release is coming up sometime in the early half of next year.
Early half, okay.
Yeah.
And what about Azure V2? Is there like any? Is there going to be additional support for Azure V2?
Azure V2.
Yeah.
There will be additional support. All of that is again coming up in the upcoming releases. We don't have specific dates as of yet. So. Yes, yes, that is the upcoming release.
Well, not for the Azure V2.
Yeah, not for Azure V2, but for Azure Web Apps, that's beta availability early half of next year, basically.
Cross-app work fine with transaction across different application contexts?
Yes, so cross-app works regardless of whether you have a PHP, Node, Java, .NET. We completely support cross-app transactions, yes.